All right, ladies and gentlemen, today I'm going to be teaching you how to do is how to identify types of reactions. Now, there are 5 different types of reactions that you'll have to be able to identify, and that is synthesis reactions, decomposition reactions, single replacement, double replacement, and combustion reactions. So you'll have to be able to identify each type of these. Eventually, you'll have to be able to predict the products. But right now, let's just focus on identifying them. So let's look at our first one. The first one is a synthesis reaction. So here's how you identify a synthesis reaction. Synthesis reactions are always 2 elements reacting to form one compound. Okay, so 2 elements reacting. How you know it's an element? If it's listed by itself. So carbon and oxygen are elements. They're listed by themselves. They're going to react and combine. And think of what synthesis means. Synthesis means to put together. So you're putting together a carbon and an oxygen to make CO2 or carbon dioxide. The general formula right here, down here at the bottom, that's just showing you that you have 2 elements, element A adding to element B to produce something combined, compound AB. So that's how you identify a synthesis reaction. Next one is a decomposition reaction. Decomposition reactions are pretty much the exact opposite of synthesis. So in synthesis, you have one compound breaking apart into 2 elements. Okay, so that's the exact opposite of a synthesis. Decompositions are the only reaction that only have one thing on the left side of the arrow. So if you just see one compound on the left side of the arrow, automatically going to be a decomposition. So notice how over here on the general equation down here at the bottom, there's just one compound. It's compound AB, and it is reacting. It's separating. That's what the arrow means. And it is producing 2 separate things, elements A and B. Next one is a single replacement. Single replacements are a little bit more difficult to identify, and that's because they can look really complicated. But really, they're not. The reason is because single replacements always have one element reacting with one compound. And that's all you have to be able to identify. If you see one element reacting with one compound, then it's automatically going to be a single replacement. One atom is going to come in and kick out the other. So in this picture right here, zinc comes in. It's kind of like dancing, really. Zinc comes in, it kicks out copper. Just like if you know, a couple was dancing, a guy and a girl were dancing, and a guy walked up, who's he going to kick out? Well, he's going to kick out the guy so that he can dance with the girl. So what's happening is zinc is a metal, and it's going to kick out copper, which is also a metal. So it comes in, kicks out copper, then you end up with copper and chlorine together on this side of the equation, or sorry, excuse me, zinc and chlorine together on this side of the equation, and copper by itself. Now the general formula right here, again, one compound reacting with one element. That's how you can tell the difference. So look for compounds, look for elements. Next one is a double replacement. A double replacement is when you have 2 compounds. Notice how here we have 2 compounds. If you ever see 2 compounds, it is almost always going to be a double replacement. You see 2 compounds reacting, it's going to be a double replacement. So what's going to happen here is actually very similar to dancing too. Calcium and magnesium are both positively charged, or they want to be. So they're not going to go together. Okay, they're both positively charged. So calcium, when this reaction happens, calcium is going to go with oxygen, magnesium is going to go with sulfur, and you see that over here on the right side of the equation. Notice how calcium and oxygen are together, magnesium and sulfur are together. So they're switching partners, just like if They were dance partners. They would switch. The general equation, notice how down here, again, this would be compound AB and compound CD react. They flip-flop partners, and they create new products. That's how you can tell the difference between double replacement. This last one, this is probably the only exception that we're going to at least study, that is the exception to single replacement. Single replacement, again, I said earlier, is when a compound and an element react. Well, here we have a compound and an element. This is a carbon and hydrogen compound and oxygen, the element. So, if you ever see a carbon-hydrogen compound reacting with oxygen, this one actually is not going to be a single replacement. This one is a combustion. So notice how here we have carbon and hydrogen compound. Here we have oxygen. Those are always going to be the reactants. They're always going to be on this left side. Then the products are always going to be carbon dioxide and water. Those are going to be the products, the things that are produced. And that's how you know that it's a combustion reaction. So let's look at a few, and I'll show you how to identify them. So here's just a bunch of mixed up reactions. We're actually just going to state the type. We're not going to predict the products yet. So we have barium chloride reacting with H2SO4. So we need to look. Is this a compound or is it an element? Is this a compound or is it an element? Well, they are both compounds. Two compounds reacting is called a double replacement. So this would be DR. I'm going to abbreviate that for double replacement. Then on this next one, we have a compound and an element reacting. Now, you might initially say, well, that's going to be a single replacement. But remember, this is a carbon and hydrogen compound reacting with oxygen, an element. This is going to, and also you'll notice the products are carbon dioxide and water. This is a giveaway of a combustion reaction. So this I'm going to write C for combustion. For number 3, now we have an element reacting with a compound, and they are not carbon and hydrogen, and the element is not oxygen. This is the one that you're going to know is a single replacement. Zinc's going to come in, kick out copper, and then you'll have your single replacement. So I'm going to write SR for single replacement. Number 4, we have two elements here. Potassium is an element, bromine is an element. They're by themselves. They're coming together to make one product. This is a synthesis reaction. Guess I could have just wrote S, but that's a synthesis reaction. Then for number 5, this is the giveaway right there. There's only one reactant. Whenever there's only one reactant, the only thing that compound can do is fall apart. And the word we use for something falling apart or a reaction with something fall apart is decomposition. I'm just going to say decomp. Okay, so I hope you found this video helpful. Again, you're just trying to identify the type of reaction. I'll give you chemical equations. You just have to say whether it's any of those 5 types, and you'll need to master that and know the difference between single replacement, double replacement, synthesis, decomposition, and combustion. Thank you for watching.